So it's 3 p.m., but no one has joined. So I will wait. Whenever people will join, we will start this session. So we'll wait for a couple of minutes. Let some other people join, and then we'll start the session. Okay, so let's begin the session. Maybe people will join later. So hello everyone. My name is Farid Anand Singh. I welcome you all again. in this live session of the course Automation in Manufacturing offered by NPTEL under the course code of NOC 22ME133. With PMRF and NPTEL PA scheme, I got this opportunity to get interact with you and solve your queries and do this live session. So in this session, like as very few are there, so I just wanted to know first of all your uh, queries or if you have any problem uh, till now in this course. So just please feel free to ask me if you have any problem or if you have any query. So before starting the session, we'll discuss your problems and queries. Is there any problem to anyone while pursuing this course? Okay. So Subham and Dalal.
Sir, no problem, sir.
Okay, okay, thank you. And Subham, what about you? So I hope you guys have already registered for the examination and preparing for the final examination so that you can get the course completion certificate after completing this course. So, okay, so this live session will be basically based on the course content that is posted in week 9. So we are in the week 9, like we are beginning the last part of this course. So this course is of 12 weeks. So we have completed 9 weeks. 3 weeks are remaining. So this week it was more about hydraulic machines and the fluid-based mechanism. So let's start with some questions that I have for you. So I hope you will be interacting with me and uh, keep answering the question. So the first question is on the screen. The question says the hydraulic systems work on the basis of which law? So is it Taylor's law, Fleming's law, Pascal's law, or Fourier's law?
Pascal law.
Okay. So one answer is Pascal law. What about other? C. Okay, Pascal law. Okay. So all of you are saying C. Yes, the answer is Pascal's law. So let us see. Like you are very familiar with uh, this diagram. This diagram is very common. So wherever you will see, there are there are 2 points. First point is this, where we are applying force, and then second point is this. So practically, you may also have seen this kind of arrangement whenever you go for washing your for vehicle washing center or maybe servicing center of any of your vehicle. So they use this kind of arrangement. So through the pedal, they used to pedal this and apply force over this side, and your vehicle get elevated at some height so that they can easily stand here and then make some repairing or washing activity can be performed. So what what is happening here is uh, this Pascal's law says that any of the force in a closed contour, if the fluid is contained in a closed container. So if any point a force or a pressure is applied, it will be distributed uniformly and it will be uniform everywhere. So like if the if the amount of pressure is P here, so again the amount of pressure P is also here. This P will be same. So when we come to here, like for calculating the formula, so suppose this is force 1. So force 1 is equal to pressure 1 and the area at 1. Similarly, for second point, this force is F2, pressure is P2 and area is A2. But P1 and P2 are same, they are equal because of Pascal's law. So what what it happens like, it will be written as F2 is equal to P. We can write P2, we can write P1 in the place of P2, and then A2. Now it is given here that area A2 is 10 times of area A1. So we'll write it again, P1 into A1 into 10. Now this P1 into A1 is nothing but the this force F1. So what what it becomes, F2 is equal to F1 into 10. So this is how you can see the, if you have applied force F1 amount of force, then at second point, due to this design change, like this change in area, this the force at that point becomes 10 times to the initial force that you have applied. So this 10 is the, is also known as the advantage, that is known as mechanical advantage. So this is a basically what this, how this Pascal's law work, and how the hydraulic system, the basic hydraulic systems work. So I hope this is clear to all, and maybe if there is any confusion, you can ask me. This is a very simple concept that I have just explained. It's just for your refreshing your concept. So I hope it is very understandable. So moving to the second question. Second question is the measure of the force amplification achieved by using a tool, mechanical device, or mechanical system is called. So here it is talking about force amplification. So what is the measure of force amplification called?
Mechanical advantage.
Okay, mechanical advantage. So I'm saying A. Okay, yeah. So again, like this, just I have explained that this mechanical advantage, it is known as mechanical advantage. What is happening in the previous problem was F2 is getting 10 times of F1. So this 10 was the this mechanical advantage. Okay. So due to this arrangement, we are getting this advantage of 10 times of force that we have applied. So it is termed as mechanical advantage. Moving to the third question. Third question is on the screen now. It is, it says like in hydraulics, the product of pressure and volume flow rate. This product of pressure and volume flow rate provide what
Power.
quantity of the system? Okay,
Power.
power. Okay, any other answer? We are multiplying pressure and then volume flow rate. B. Okay, yeah. So yes, it is power only. So these are the some formula that you can remember or you can reverse. Like if you want to calculate the hydraulic power in kilowatt, so in academics we prefer kilowatt, but when you go to market, then this horsepower is the popular term. When you go to purchase some uh, device, some motor or some generator, some kind of equipment, if you want to purchase, then horsepower is used. Okay, so these are the two formulas and in different units. So if the flow rate is in liter per minute and then pressure is in bar, then you can apply this formula to get the hydraulic power in kilowatt. And then if you want to get uh, it in horsepower, then you can apply this. So these are the some constant values due to the unit changes, unit conversion, which is there. Moving to the fourth question. Fourth question is the centrifugal pump is an example of which type of pumps? So I hope you have seen centrifugal pump and also studied about that. So what
Hydrodynamic pump.
hydrodynamic pump? Okay. Any other answer? One answer we got hydrodynamic. D, positive displacement. One answer is here. So I'm saying D. One is here. Any other answer? Okay. So Shubham, it is wrong answer for you this time. It is hydrodynamic pump. Okay, so positive displacement pump is something where there is a displacement of liquid occur because of some piston action. Okay, so if you have seen uh, the general hand pump kind of thing, that so like this, and then there is some water outlet. So from ground, if water is coming here, so first of all the water comes inside it, this area, and then when we move the piston up and down, so this water flows like this. Okay, so this is what the positive displacement type of pumps. Okay, so if this is the manual pump, similar kind of pump, similarly we can also have the electric powered pump. Okay, so where this kind of action occurs, so what is there, the flow is intermittent. Okay, so whenever once you just press this handle, the water comes out. Another time you press, then another time the water comes out. Sometime what happened, not fully intermittent, but it is like the flow rate increases and decreases. So when you press this pull this handle, so what will happen, large amount of water will comes out, and then once you like that action ends, so water, the flow rate becomes slow, so it becomes slow. So again you will press the handle, and then again the amount of water comes in large amount. So that is an example of the positive displacement pump. This is an example of that. However, the centrifugal pump, which is like this is the general kind of like pumps that you have seen at your home for lifting the water from ground to tank or something like that. So these works on the centrifugal forces. So application of centrifugal forces. So due to that application of centrifugal forces, what happened, the pressure difference is created, and water comes from out inlet here, and then it throws the water to with more energy and more power, so that it can lift to some other height. Okay, or wherever we want to collect the water. So this is the centrifugal pump is the example of hydrodynamic pump. I hope it is clear now. Moving to the next question, question number 5. Question number 5 is on the screen. It says, which one of the following would be best suited for convey cherries, tomatoes, or fruit pulp in an automated food processing industry? So, what kind of motor you find when you process at your home also? You process some fruit or some vegetables for extracting the juice or something kind, some pulp kind of thing. So, what kind of motor you have seen? Like, what is that? What pump? What kind of pump? What kind of motor you call it?
Lobe pump.
Lobe pump. So one answer we got is lobe pump, and again Vikas is also saying lobe pump. Okay, so yeah, it is a lobe pump. So whenever if you haven't seen, just you can see it. It's look like this. It worked like this. Okay, so from the top view, if you see, so it is like that. So one is the entrance zone from where you the like you can put this. My voice is low. Okay, I will try to speak louder. So not is audible. Vikas, please confirm. Hello, hello. Okay. So thank you, Zohan. Yeah. So so this we are talking about low pump. So low pump. This is the inlet point. You can see from where you used to like we used to uh, uh, give the like input as a like raw fruits or raw vegetables, and then after mixing or then the juicing action happens, and from here you'll get the juice or pulp, that whatever you want. So these kind of pumps are used in processing the foods, okay, in the automated industry also. So this pump are known as low pump. Now Next question. It is a different kind of question. It is first time you are seeing this match the correct pairs type of question. So these are the pump and then construction features. So you have to match the correct one from pump to the construction feature, and the options are here. So there are four probabilities are given here. So which is what do you think which is the best suited option? So just take your time and just try to answer this question. Okay, we got one answer. C. Okay, we got one answer as C. Okay, Vikas is saying D. One answer for D. One more answer. We'll discuss this question. C. Okay, so two people are saying C. One is D. Okay, so answer is C. So why C? Let's match. Why not D? So I know like there is a confusion. There must be a confusion. So we'll discuss it. But this A is clearly this vein pump is having radial slot. It is very clear. Now, when you see C internal gear pump and you read the option number three, that unequal number of teeth on internal rotor gear and external idle gear, it is correct. This can be matched with three. But when you go for generator pump, so generator pump does not contain this crescent. Generator pump does not contain this crescent. Okay, so this B cannot be matched with A. So the option is like B can be matched with only three, which is left. This internal gear pump has crescent. Okay, so they have crescent, but this generator pump they don't have crescent. So that's why we call this generator pump as a special case of internal gear pump also. Okay, so it also has internal gears, but it doesn't have any crescent. So that's why this the correct option is B is matched with three, and then C is matched with one. What is crescent? Okay, so I have to draw the diagram. Give me a moment. Just give me. I will show you. I'm taking long time. Just give me a 1 minute more. I'm downloading that GIF kind of thing so that you can be explained in a very better way. So just put in the slide. Okay. So it is here now. So we are talking about that crescent. Okay. So the crescent is this point of the pump. Okay. So what it says, like it is already written here. So I just copied it from source from internet. That this is a like this is the internal gear pump. Okay. So as you see, these are the internal gears, and then gear is this one is rotating and another is stable condition and unstable condition, and then what happens? It is getting engaged with other and then performing the action. So what is there? So this crescents, if you read like this statement, so as the teeth separate, they pass over to intake the whole. Okay, so they suck fluid, they suck in the fluid. Then the gears are separated by crescent seal, as shown in brown color. So these are the crescent seal which are used to separate this, like this engagement, like this. These are responsible for the engagement and disengagement of the teeth, the tooth of the internal gear pump. Okay, so these are the crescent. This is what crescent is known as. So this crescent is absent in the that what we are calling this girator pumps. So in girator pumps, this crescents are not there because it has like some square kind of shape. This kind of gears were there in the crescent. This girator pumps. Okay, so these kind of what you can say teeths are there. So engagement and disengagement are done like this. This is used to rotate, and then uh, these are without crescent, and but they are also known as they can be they are the like a special case internal gear pump. However, in this kind of this in the common internal gear pumps, we can find this crescent, which are responsible for separating the or which are responsible for engagement and disengagement of the tooth. Okay, so I hope this it is clear now, Vikas. Is there any question? Okay, thank you. So moving to the next question. Question number 7. There it says the flow rate of Swass plate type axial piston pump increases when Swass ankle. So we are increasing the flow rate of Swass plate type axial piston pump. So what we have to do with this Swass angle? So we have to increase, decrease, zero, or doesn't have any effect of this Swass plate angle.
Swass plate angle increases, flow rate increases.
Okay. So the option is increases. So if we want to increase the flow rate of stress plate type axial piston pump, so we have to increase the stress angle. So is there any other answer? Let's see. B. Okay. So it is again this increases. Yeah. So whenever we increase the stress angle plate, the angle of the stress plate. So what is happening here? So if you have seen the stress plate type axial piston, so it has like this kind of plate is there. So if we increase the angle like this, so what happened? The length of this increases, right? So because this is same and then this point are same, so this particular length get increases from this by this much amount. Okay, so this much amount the liquid that what you can say that the fluid get more fluid will be contained here. So that's why this flow rate whenever like it is this motion is continuous, so this movement is continuous, so that's why the larger flow rate we get. Okay, so moving to the next question. This question says in hydraulic pumps the process of rapid creation and subsequent collapse of air bubbles in fluid is called. So not
KVT.
only Cavitation. Okay, so there are two options. We got cavitation. Yeah, so it is not only hydraulic pump, but also you can see whenever the fluid is flowing in the normal pipe or something like that. So if due to some pressure changes, if air bubbles comes out and then again it pops. Okay, so it pops also at next moment only. So here it created and here it pops. So this kind of rapid creation and subsequent collapse of the air bubbles uh, causes harm to this pipe. Okay, though the material of the pipe may get eroded sometime because of this. The explosion is more having more like it's powerful. Okay, so we usually try to avoid this cavitation kind of thing whenever we used to build a this hydraulic system, or we used to uh, make some arrangement for flowing the fluid. We try to discard this kind of possibilities of creation and this collapse of this air bubbles. So answer is obviously cavitation. So next question is, which of the following pumps offers self-priming performance? So before answering this question, I just wanted to know what is priming first. What is this priming phenomena? Can anybody explain this priming phenomena for me, or have you seen this, or have you done this? So one answer is here. Have anyone had anyone seen or done this priming operation for any of the pump or something like that? Hydraulic removing air. Okay, yes. So what we do for removing this air, and what is the effect of this? If why this air is more like what is dangerous or harmful, or possess some limitation? Why we have to do this priming? So whenever you go to some maybe if you village side where this uh, pumps are there for irrigation purpose, the pumps are used for irrigation purpose, or sometime also in this fire fire station also the pumps are there to fill the tankers. Okay, so what happens, so those pumps always require this priming. So what does priming basically mean? Priming is a process where we are removing the air from the cavity of the from the vicinity of the pump. Okay, so what we do, we used to fill the water, okay, from the mouth of the that wo- from where the outlet, from the outlet mouth of the pump. So if this is outlet mouth of the pump, we used initially before starting that pump, we used to put some water inside it. Okay, so that water get into it and the area get filled with water. Okay, and then again, then we used to press the button for this motor to rotate this uh, for rotation of this rotor. Okay, and then this then it starts quickly. If we not do this and we just try to run this motor, so there are air, like because of that gap, air is there, and due to that air, the pressure difference is not able to build up. So if the pressure difference will not build up, how it will suck the water from the maybe from ground, inside ground, or maybe some at lower point, and then push it to some higher point. Okay, so for this, because of like for this we have to do this priming. So in older kind of like the technology, this self priming was not present initially. So sometime at our home also, if in village side, not in the urban area, if you have seen the hand pumps. Okay, so sometime it get out of water. So what people used to fill the water from outside to it, and then start doing pumping, like pumping operation, and then after some time it starts uh, throwing some water. Okay. So yes, in gear pump is the newer kind of technology which came to do this self priming. Okay, so in gear pumps we do not need to do priming operation because it is the self priming operation is done by this pumps. So yeah, this is what I was discussing about at all. So this is the liquid, like we have to fill the liquid and fill this area with the liquid so that after it start before starting the air from this vicinity goes out, and then once it will be filled with water and we start the motor to rotate this rotor, and then the suction operation will easily perform. I hope it is clear to all, and I hope you have also visualized the scenario of what is self priming and priming operation is all about. So moving to the last question. So this question says, as the pump lift increases, the efficiency of hydraulic pump get decreases or increases, or it does not have any effect. Okay, so we got one answer. One answer is A. Anyone else? Again, one answer. Two answers for A. Okay. So the answer, yeah. So answer is decrease only. So what is pump lift? So basically, suppose this is the level where our pump is placed. Okay, so suppose here we have placed our pump, and this is another level from where we have to get the water. This is the water level from where we have to pick the water, and then at suppose some this height our tank is there. Okay, so tank storage is there. So and this is the water level. So this particular height from where the pump is lifting the water, okay. So this height is known as pump lift. Okay. So if we increase this height, so what will happen? We obviously the efficiency of the hydraulic pump decreases because every hydraulic pump has like its efficiency is defined based on the value h. Okay, so that whenever you go to in some shop, you used to like for purchasing this pump, they will ask about this this parameters. Up to what height you have to throw the liquid, and from which height, like from up to what from what depth you have to suck the fluid. Okay, so all these are the parameters that you have to know before purchasing any of the hydraulic pump. So so if we increase the pump lift, obviously the efficiency of the hydraulic pump get decreases. So that's all from my side for this question answer session. Now, this week I haven't taken any question from the portal because there is no relevant question. All the questions that are asked we have already discussed in the earlier weeks. Okay, and so and one or two questions are there. They're very similar that we have already discussed. So we are now open to you again. So if you have any query, if you have any question, you can ask me. Yes, Vikas, you are raising your hand. Any question? So if you have any question, please ask regarding this course, regarding anything regarding this course, you can ask me. Or if you want me to repeat some concept next week, you can just ask me. I can just prepare that, and then we'll discuss in uh, next week. If you have any like because 9 week is completed, so nine in this 9 weeks you have studied lots of concepts. So if you feel that that some particular yes, Vikas, your hand raising your hand, please. You want to say something, Vikas Kumar?
Hello,
Yes.
I'm audible.
Yes, Vikas, you can speak now.
Good afternoon, sir.
Good
Sir,
afternoon.
my question is in a lecture week 9. Uh, Professor Joshi said that a centrifugal pump is a non-constant pump, and a reciprocating pump is a constant discharge pump.
Constant discharge. Okay. In the lecture, like in the video lecture.
Yes, yes, sir.
Okay.
One minute. I confirm.
Yeah.
Sorry.
Maybe sometime what happens, like this is not the thing, like as we all know that the reciprocating pumps are always what you can say,
Professor
intermittent.
Joshi said, hello.
Yes, yes.
Professor Joshi said, for a positive displacement pump, it deliver a constant volume of fluid in a cycle.
Mm-hmm.
The discharge quantity per revolution is fixed, and
Mm-hmm.
for a centrifugal pump, the delivery is not constant.
Mm-hmm.
I don't get it. Why the delivery volume for a centrifugal pump is not constant?
No, no, no. So there may be some what you can say, some kind of like mistake or something happen. So the first statement is already like it is right. So, but for
Yeah.
centrifugal pump, as far I know, like from my knowledge, that like there may be some issue, or some maybe you wanted to say something, but what mismatch of word may happen. So in centrifugal pump, always this. Can you repeat that statement? What was that? Centrifugal pump. What he said?
Sir, can I answer this question, sir?
Yes, yes, yes. You can. Yeah, we are here to discuss, no issues.
In a positive displacement pump, we have a inlet valve and outlet valve. Let's consider a reciprocating pump. So for each cycle, the volume of fluid is constant. But in the case of
Yes.
centrifugal pump, the flow rate is depends upon the speed of that pump.
Yes, yes.
So for a given constant, for a given cycle, that volume flow rate may not be constant in case of centrifugal pump.
Okay. Yes. Yes. So yeah, you are
But
right. Absolutely
hello,
right. So if this, yes, Vikas.
hello. But for the centrifugal pump, speed change in every cycle. Speed change for the
No, no,
for
no,
a period of time, and thus there is cycle
No.
in that period. Many cycles in that period.
Okay.
For
In case of
speed change, yes.
yes, I will tell. In the case of centrifugal pump, the volumetric efficiency is there. Actual volume handled by the fluid to the theoretical volume. So that volumetric efficiency will vary, not the speed. I will correct my answer. That volumetric efficiency is not constant for centrifugal pump, but for the positive displacement, we'll have a volumetric efficiency always above 90 percentage. So the flow rate is constant. So you will get a fixed displacement volume in the case of positive displacement pump, but for the centrifugal pump, you won't get a constant flow rate. Because in the positive displacement pump, fixed quantity of the fluid only enters, then valve closes. After that only you are getting a discharge. So per cycle, you are getting a constant flow rate.
yes. So yeah, you are absolutely right. Like for positive displacement pump, it is already clear that we are getting for a cycle the amount of fluid is same. So for,
I
yes,
hello.
yes.
I
So
understand for that. Yes.
for
Yes.
yes, so for centrifugal pump, what it is happening, like if you talk about cycle to cycle difference, so the flow rate may changes. there are two reasons that that is occurring from the like coming out from the discussion. So one is this that this Shankar Lal is discussing about the volumetric efficiency. So if the volumetric efficiency is
Hmm.
not constant, then the flow rate is not constant. So in a simple terms, you can understand. So centrifugal pump work in the on the principle of like with the action of centrifuging action. Okay, so what happened? The difference of pressure is created from the outer what you can say outer parameter of the rotor to the to its eye. Okay, so we call this eye and then outer side. I'm not getting that term. So the pressure difference creates the and causes the flow of liquid. The liquid comes inside and then it throw away at some other pressure. So if the volumetric efficiency is not constant, then this phenomena may like sometime amount of liquid will be more if the pressure difference is larger, and sometime it may be less. So that's why this the what can say flow rate may changes with the changing cycle. Okay, although what happened, like when we use this electric motor, so the speed of the motor is always constant. So I can understand what is the confusion to you, like the speed of this rotation is constant, then why not the this flow rate is constant, right? So because of this kind of loss like volumetric efficiency, and then maybe this pressure difference is not always that this the creation of pressure difference is not always same. So because of that, if we compare the like cyclic flow rate, so maybe there is some slight changes in that. Am I right? Like Shankarlal, impeller casing, yeah, yeah. So casing is like outer side and then impeller is inside. Okay, so is there anything need to be corrected? I think it is justified now. Or anyone else want to comment on it? You can. Okay, Vikas, thank you. I'll try to search more prominent answer for this. Maybe we'll discuss it more in next session also. Anyone else want to ask any question, or you can give some suggestions or anything, or improvement in this course or in this live session or something. You can feel free to ask, or you can speak anything if what you want to say. And I just said ki if you have any confusion in or any query in any of the topic from any of the week that we have already discussed. So if you have any query, you can just ask me. We can discuss it more if now also, and then next session also I can make some special slides for that, and then we'll discuss that also. If you have any of the concept is not clear or is there any confusion left. Please interact, please speak. So the session will be more fruitful when you speak. The discussions are more helpful for you, for all of us actually. So for like those who are new today, so I just want to inform you that the question paper, if you have registered for the examination, the question paper will consist of 50 multiple choice questions only. So and then there will be no negative marking in that. So you have to prepare your this course for accordingly. Prepare for examination. Uh, Maybe you will find some numerical questions that to be the options are there. So the easily solvable numericals will be there, and maybe this kind of match the following questions that are converted to the that can be converted to the multiple choice type. You will get a fill in the blanks type of options. This question you're already familiar. So the type of question that we are covering, you can expect this kind of questions in the final examination also. Anyone want to say anything, or if not, then we'll end this session now. So we still have 10 minutes. We can discuss if anyone have any query or anything to say. Thank you very much, Shankar Lal. So discussion, like, thank you for your participation in the discussion. So we can have more ideas, more thoughts on any of the problem. Okay, so now we are, I think time is also over. So I'm just ending this meeting. We'll meet to next meet on next Saturday on same time with same meeting link, and we'll discuss about the course code of, oh, sorry, about the course which is covered for week 10. So thank you very much, everyone.